Welcome back, Math 10, to your second lesson on rational exponents. So today, to start off, we're just going to go over our power laws, okay? So our first one is the product law. So the product law of powers, well, that's the same as x, n, plus m. We just add the tops together for multiplying them. Next one is power of a power. Well, that means multiplication times n, right? We just multiply my exponents together. The next one here, I'm going to put this as y, power of a quotient. Well, that's x to the m over y to the m. Both of these are to the power of m, or this m exponent must be multiplied to both of the exponents on the inside. Remember, there's an imaginary 1 there. Next one is the integral exponent. Well, if you remember, that means to flip. So we have 1 over x to the power of m. Our next one here is the rational exponents. Okay? So rational meant, well, we have to put this is my exponent, so it's x to the m, and then we have to go to the nth root. That's it. Now this next one is quotient law. Remember, quotient law meant to subtract. When we divide, we subtract. So that's x, m, subtract n. We subtract exponents. My last one is power of a product. Well, this m must be multiplied into both exponents. We have x to the m and y to the m. Right? Very similar to power of a quotient, power of a product are very similar. So let's start with our first class example here. It says, write each power as a radical. Well, I look at this, we have x to the power of 1. I don't have to write that. And then this here means we want the 6th root of it. Let's take a look at my next one. Well, this base 5 has a power of 1. There's no brackets around all of this. There's this the exponent 3 over 4 only refers to t. Okay? Because there's no brackets. So I just have 5, and I have t to the power of 3, and the 4th, right? This is t to the power of 3, and then it's 1 over 4, the 4th root. So that's that one. Let's take a look at example number 2. Simplify each power with positive exponents, and then as an entire radical. So we want positive exponents, entire radical. This first one here, I look at this, that is product law. That means we must add our exponents. Remember, there's a little 1 there. There's an imaginary little 1. So I'm going to have x to the 1 over 2 plus 1. Okay? Now, if I want to add 1 plus 1 over 2, we're adding fractions. That means we must have common denominators. So this is the same thing as 2 over 2 is the same as 1, isn't it? Plus 1 over 2. So 2 halves plus 1 half will give me 3 halves. So this is the same as x to the 3 over 2. Now it wants it as an entire radical. We have an exponential form, now we want it as a radical. So that's going to be square root of x to the power of 3. That's it. Here's my final answer. Let's take a look at the next one here. We're using division. Division means to subtract. So I'm going to have y to the 1 over 3 subtract 5 over 3. Well, we have the same denominator here, so we could just subtract the numerators. This is going to give me y to the negative 4 over 3. Because 1 subtract 5 is going to be negative 4. So now the next part says we want positive exponents. So if we want positive exponents, what we must do now is flip it. So we're going to have 1 over y to the 4 over 3. Now when we flip it, the key thing is we're not going to flip our exponents. We only flip my base, never the exponents, just the base. So we continue this. I know I have 1 over y to the power of 4, and then we want the 3rd root of that. And that's it. Just like that. Okay? Let's take a look at my next one. Well, this here, we have power of a power. So that means we must multiply our exponents. So this is going to be multiplied into that. So I'm going to get a, 1 over 2, multiplied by 2 over 3. Well, multiplying fractions is we multiply tops, multiply the bottoms. So that's going to give me a to the 2 over 6, which is the same as a to the 1 over 3, which is the same thing as the 3rd root of a. Okay? Last one of this section. So here we're going to have to multiply this 1/2 into both the top and the bottom. So I'm going to get x squared multiplied by 1 over 2, all over y to the 1 over 2. Power of a quotient. Well, what's 1 over 2 times 2? Half of 2 is 1. So we get x all over. And this we have to put into radical form. Square root of y. And there we go. We are done. All right, let's take a look at example number 2. Simplify the following. Write each expression as a power with positive exponents and then as an entire radical. So I take a look at this first. I have this 4 and the 3. These exponents only refer to the x's, right? And this 4 and 3 have exponents of 1. So let's multiply those 4 and 3 together first. That's going to give me 12. Now we have product law. This multiplied by that. So I have x 3 over 4 multiplied by x negative 1 over 2. So I can add those exponents together. But I need common denominator. So this here is the same as negative 2 over 4. So I have 3 over 4 plus negative 2 over 4 gives me 1 over 4. So I have 12x to the 1 over 4. So that's the same thing as 12, and we want the 4th root of x. That's it. There's my solution. Let's take a look at my next one. First of all, I look at the numbers, right? They have no exponents. Well, 5 over 25 can be simplified to 1 over 5. So I have 1 over 5. Okay? Now, I'm going to flip this. I have a negative exponent. I don't like that negative exponent, so I'm going to flip it. So I'm going to have x to the 3 over 5 multiplied by, and this is going to go on top because of the negative exponent, x to the 3 over 5. Now I'm going to use my product law, which will end up giving me 1 over 5, x to the 6 over 5. I add the exponents together, same base, so I could just add them. Now that is the same as we have the 5th root of x to the power of 6, and that's all over 5. Okay? Now, another, or 1 over 5 times that, just divided by 5. Now, another way of doing this is I could have gone 3 over 5, subtract negative 3 over 5, use the quotient rule on that. And that still would have given me 6 over 5. So there's more than one way of solving this one, or approach to getting there. Let's take a look at my next one here. We want power to a power. But this power here is to both of those. So I'm going to end up getting 8 to the 4 over 3 because of the brackets, so we put into both. And we have 8 to the 1 over 2 multiplied by 4 over 3. Okay? Well, what does this give me now? I want to first find the cubed root of 8, which is 2. 2 to the power of 4 is going to give me 16. So it's like 2 to the power of 4, which is 16, because I first did the cubed root of 8. And this here, multiply those together, I'm going to end up getting 4 over 6. I believe, yep, okay. So we do this, this is going to give me 16, and that's the same as 2 over 3. If we simplify that, a to the 2 over 3, which gives me 16. And here we're going to get the cubed root of a squared. And there is my final answer. That's 16. Okay? Let's take a look at our next example. Write each as a radical power. Okay? So write each radical as a power. Okay? Write each radical, this should be as a power there. So we have a to the, well, this is the power, a to the 5, and then we divide it by 3. Okay? That's an a. Next one is a to the, 1 over a to the 7 divided by, there's nothing there. If there's nothing there, we have to pretend there's a 2. Now, I look at this, this is also the same as a to the negative 7 over 2, because we could flip it, right? So it's not in fraction form. Both of these would be correct. Okay? Let's take a look at my next one now. Evaluate as a power. Okay, so write as a power, then evaluate. I look at this one, I have a little bit of a problem. So first I'm going to do this inside. So that is the square root of 1, 2, 9, 6 to the 1 over 2. Okay? Now, this here means 1 over 2 as well. So I have 1, 2, 9, 6 to to the 1 over 2, 1 over 2. Now I have power to a power, so I can simplify this. What's 1/2 times 1/2? 1/4. Okay, so I'm going to have 1,296, 1,296 to the 1 over 4. Then I could punch that into my calculator, and I'm going to get, I believe, 6. If we punch this into our calculator like this. So we get 1,296 to the power of 1 divided by 4. Okay, see how I have that? Push enter, and I am going to get 6. Okay? Now let's take a look at the next one. So this is the same thing as 1 over 169 to the 1 over 2. So that's going to be 169 to the negative 1 over 2. Now, this here is the same thing as, I could say, 1 over 13, because the square root of 169 is 13. This is probably your best answer, is that. Going to the negatives doesn't really help. Okay? Normally we want them as a positive exponent anyway. So let's try this next one here. So we have square root of 64 first. So if we want, we can even do that first. So we have, but wants us to write this first. And we have 64 to the 1 over 2. Okay? Then we're going to have 64 to the 1 over 2, and this is the third root, to the 1 over 3. So I could simplify this first and go 64 to the 1 over 6, power of product, or I could square root 64 first. First, 64 first, which will give me 8, and then I go cube root of 8 is 2. And that's 2. Or I'd multiply 2 together 6 times, that gives me 64, so 6 root of 64 is 2 as well. So there's more than one way of solving that one there. Okay, let's take a look at example number 5. Right, each has a, so we have a value, x to the power of n. So here it wants us to cube root everything. So I'm going to separate. This means 8, cube root of 8, then we're going to have cube root of x. 5. Okay. So what does this simplify? Cube root of 8 is 2. So it's going to give me 2, and this is 5 over 3, x to the 5 divided by 3. And there we go. Done! Let's take a look at my next one. So we want the 5th root of each thing, so we want to separate both first. So I want the 5th root of 32, and we have x to the 3 over 5. Well, what is the 5th root of 32? 5th root of 32 is 2. So that's 2, x to the 3 over 5. Okay? If I want to see, I just go like this. 32 to the power of, now I hit this little hat button there, and then I go 1 divided by 5. Push enter, and we get 2. Okay? Let's take a look at my next one. Here, we look at it, we have product law. So let's see what these are first in rational exponents. So I'm going to have x to the 5 over 3 multiplied by x to the 1 over 3. When I look at that, that's going to give me 6 over 3 if I add those together. So it gives me x to the 6 over 3. So I continue this. This is just x squared. And we're done. That's it. Let's take a look at my next one here. We have that 2. Now 2's on the outside, so I'm just going to leave that at 2. Then I have, x to the 1 over 2. And here is x to the 1 over 3. Now, this is product rule, so that means we must add our fractions. So what is 1 over 2 plus 1 over 3? We need common denominators. My common denominator is 6. So it's going to be 3 over 6 plus 2 over 6, which gives me 5 over 6. So I get 2x to the 5 over 6 as my final answer. Okay, there we go. Almost done. We're on our last set of questions now. So here it says, write an equivalent expression using exponents. Okay, so we want an equivalent expression of exponents. We have a square root of a square root. So I'm going to leave that with a to the power of 3, all to the 1 over 2. That's square root. Now we have to get rid of the next square root. That's another 1 over 2. So that's a to the power of 3, all to the 1 over 2. And then we have this to the 1 over 2. So I look at this, power of a power of a power. So first we multiply these together, that's 3 over 2. Then I have to multiply by 1 over 2. So I multiply those together, I'm going to get a to the, what is this, 3 over 4. And that's my equivalent expression using exponents. Or I could even say this is the same thing as a, we want the 4th root to the power of 3. So it could also look like that. Let's take a look at this next one here. So we have the cube root. So I'm going to have 64. And we have v to the 6. And we want the cube root, 1 over 3. And there's still a square root sign. Now we've got to so we got rid of that one. Now we've got to get rid of the cube roots, the square root sign, right? That's the next step. So I'm going to have 64 to the 6, 1 over 3, then one more time, 1 over 2. So I look at this, first I'm going to put this 1 over 3 in, so I'm going to get 64 to the 1 over 3, and then we have v squared, right? This times that. There's an imaginary 1 there. Then I have to multiply in the 1/2, which is going to give me 64, 1 over 3 times 1 over 2 is 1 over 6, and this is going to give me v. And as we learned earlier, 64 to the 1 over 6 is the same as 2, so it's just 2. V is your answer. Okay, and you're done. Now let's try our next one. Okay, so I'm going to first do what's in the brackets, simplify those the best we can. So I'm going to have x to the 5, right, divided by 4. Then we get y to the 3, and then we have to divide by 4. And this is all to the 3 over 2. Now let's multiply everything here out. So 3 times 5 is x to the 15, and 2 times 4 is 8 over 8. Next one here is going to be 3 times 3 is 9, y to the 9 over 8. Okay? So I could leave it like this as an answer, or you might even have a question like this. So this is the same thing as, I could separate these fractions, meaning we have a whole x here, right? So we have a whole x, and we have x to the 7/8, right? Because this is the same as 8 over 8, which is 1, and x to the 7/8. And we could have a y, which is 8 over 8, and y to the 1/8. Okay? Now if I combine these are all square root of 8s, these are whole out, so I have x, y, and I could have square root, and I could have, or 8th root of x to the 7, and then y. So I could also do that. If you're stuck on this, if you're stuck on this last step here that kind of got cut off, make sure you ask me tomorrow, and I'll help re-explain this to you, okay? So basically what I did is, this is 1. So I have x to the 1. Then I have a y to the 1. Then I have still the 8th root, and there's 7 x's in the 8th root, and there's 1 y in the 8th root. So I have the square root of all of that. Okay? So I'll just do it one more time. So we have x, y. Those are done. Then we have the 8th root of x to the 7, and we have the 8th root of y. That's what that's saying there. Now I can combine these into that. This times this, same root, so we can combine them into their house, put them in there. So hopefully you understood everything. Good luck as I see you tomorrow and we'll work on these together.